Hey guys, what's up? In today's video, I have a super awesome pair of servers to show off and do some upgrades on. So we're just going to do another one of these little POV videos where I record it with my phone very shakily and you can hear my breathing 90% of the time because I talk faster than I can breathe. So anyways, right here we have a Dell PowerEdge R640, although this one's a little bit special. They don't call it an R640 directly. They call it a Dell VxRail E560F. As you can see right here, it's a Dell EMC VxRail. These servers were designed specifically for virtualization back when Dell owned VMware, and this is a super cool system. Now, as you can see, this system is basically already configured. I have another R640 right there that needs a similar configuration to this one, so we're going to be building that out in today's video. But I really quickly wanted to show off this one while I have it in front of me because I was just doing some stuff last night to test it out and make sure that I had the configuration set so that we have a standard configuration for all of our 1U Dell servers. So what's special about this server is basically it is a 1U server, so it takes up a lot less space in our rack space in our data center, and it's got dual Xeon Gold 5120, so these are 14 core, 28 threads each, so we have a total of 28 cores and 56 threads in the system, as well as 384 gigabytes of ECC registered DDR4 running at 2666 megahertz. These DIMMs are super cool. Let me pop out this thingy-madoo and take out one of these DIMMs to show off. There's a spider on my arm. Yeah, it's very dead, by the way. Anyways, now that that's done, we have a 32 gig DIMM of ECC registered DDR4 2666 megahertz that you can see. Come on. Well, it's a little out of focus, but you get what I'm talking about. And we've got 12 of those DIMMs because each of these CPUs supports 6 channel memory. Let's pop this back in carefully because I don't have replacements for these DIMMs. Yeah, this server actually came pre-configured like this. It came with all these DIMMs, and I paid less than $1 per gig for this entire server, which is super awesome. I got a great deal. Unfortunately, there were not two, so I paid a lot more for my other system, but you'll see why in a minute. So real quick, a couple cool features of this besides the 28 cores and 384 gigs of RAM is we have this boot card here, which takes dual micro SD cards that run in essentially a mirror, so a RAID 1, where you actually put your boot operating system, which is typically a hypervisor. It was designed for something like VMware, ESXi, but we're going to be putting Proxmox on it. Same thing. You put your hypervisor on here and you store your virtual machines on your actual storage bays in the front. We have this server configured with dual Intel X520 10 gig NICs here in the back, and it also has a quad port X720 or X710, I think it's called, which is on board. It's part of the OCP slot. And we actually have it configured with an NVIDIA A2 graphics card. This is a 16 gig of GDDR6 card, and it's a low profile, and it's got no display outs because this is mainly going to be used for encode and basic remote video acceleration because we can't use it for too much more due to the licensing. But that's all we really need it to do, and we have the drivers straight from NVIDIA, so it does work for that. Now we'll show off the front bays a little bit. Right now we have it configured with 6 SSDs. It's actually some of these Kingston 1 terabyte KC600s that I've grown to know and love, and we actually have a stack of them here because we're going to be splitting off and putting some of them in a different server. We also have 4, you can see these blue cables, each one can do 2 NVMEs, so we have 4 NVMe bays in the front, which we will be using later once we get our NVMEs in. Unfortunately, I won't be able to show that off because I won't be here to put them in the system. But this is the model drive we'll be using, the Kioxia CM5Rs, read intensive, 3.84 terabytes in this case, but we're going to have a bunch of 1 terabyte NVMEs, which we'll be putting in the system, and they do fit. So, yeah. Like I said, unfortunately, I won't be able to show that off. Okay, so here we have the other Dell R640. Now, this is just called an R640. As you can see, it doesn't have the VxRail logo on its front plate. It just says Dell EMC. EMC is a company Dell bought and then, did a Dell thing and just made it worse, as they do. But this one is special. I paid a little bit more money for this because of a very specific feature that they didn't actually advertise, which is cool because if they knew what they were selling, they probably wouldn't sell it for as low of a price they did. But the special feature about this server, which I have showed off in a short, is these cables. These cables allow the entire front bay, except for 2 slots right here. The 2 first slots aren't, but every other slot on the front bay, every single drive bay up here, is actually NVMe, except for these first 2. So we can put 8 NVMe SSDs in this, and then 2 SAS or SATA drives that run straight off the motherboard's PCI Express lanes using these special connectors, which each of them carries an 8x PCIe signal, which splits off into 2 drives in the front. So we're at the end, we'll be putting in probably 4 of these. I see 6. I have 6. Wait, why do I have 6? Wait a minute. I put 6 in this one. How do I still have 6? Yeah, I put 6 of them in here. I don't know how I still have 6. Anyways, we're going to be putting 4 of them in this system, and then we'll figure out why I still have 6 left over. And then we'll be putting 6 NVMEs in here because it can support more NVMEs than the bottom, and that'll give us a super cool amount of redundancy between the servers. We can talk about that more in a different video later once these get deployed and stuff and how we're doing that. Basically, we'll be using some TrueNAS tomfoolery to get some cool redundancy going where we'll end up with only 6 terabytes of networked storage, but it'll be like fully redundant, which is super important when you're delivering enterprise level, hosting and stuff. So what we have to do in this system is clearly upgrade the RAM today because we only have 2 32 gig DIMMs, which for a total of 64 gigs, and single channel per CPU is not enough. These are SK Hynix or Micron. Nope, these are Micron 32 gig 2666. So unfortunately, we're actually going to just have to take both those out because we don't want to mix and match RAM speeds. And we're going to be using different RAM for this entire server. RAM is important because for the SATA SSD pools, not the NVMe ones, but for the SATA pools, we're going to need RAM acceleration for caching. And the best way to do that is just have a ton of RAM, even if it's not the fastest RAM on the planet. So here we have 10 DIMMs of DDR4 26, no, these are 2133. And we have 32 gig DIMMs here. So we have 10, and we'll be putting in 2 more to give us a total of, again, 384 gigs of RAM in this server. Each one of these is getting 384 gigs. One of them will be slightly faster, but these servers have to be as identical as possible. Now, this one actually has 2 Xeon Gold 6130s, which unlike the Xeon Gold 5120s, these are 16-core, 32-thread CPUs, so we have a total of 32 cores and 64 threads, which in our case, since these servers are going to be designed to be almost identical, is close enough. They'll have the same amount of RAM and all that, so they'll be able to host the same amount of virtual machines, because realistically speaking, both are slightly overkill in terms of cores and threads, because these are going to be running virtual routers, iSCSI-based storage, so that's basically internal storage that we can compose over the network. It's really cool. I hope to do more videos about it in the future, but if you're interested in learning a new topic and you want something like that's actually really, really cool, learn about iSCSI. It's a really awesome way to do network-based storage. We can literally boot these servers over the network using iSCSI, and it treats it like an internal drive. It's super awesome. We're just throwing our DIMMs in here indiscriminately. I'm kind of rushing through these because I have until like 8 p.m. tonight to finish all these servers and get them packed up and ready to go to the data center. It has dawned on me that I am running out of RAM. I've only got like 1 more tray and I have a bunch of more nodes to do. So that might be a slight issue. I probably shouldn't have been putting 384 gigs in servers I was selling on eBay. And I don't really have time to buy new RAM, at least not quickly. Though I can always throw more in when I'm installing in the data center because I go and do my own installs. Because I just want to be sure, given that these are these servers are critical infrastructure. They're going to run all of our remote management stuff. They're going to run all of our storage and all of our routers and stuff in the data center. So these are the most critical servers we have. Now this one is also configured with a quad port 10 gig fiber SFP plus NIC. But as you can see, our risers are completely empty. So we're going to pop the 2 out here and we're going to throw in some extra cards that we have. And we'll talk about that as we're doing it. So that's the connection for this, the connector for this riser. It's this weird this carries a ton of PCIe lanes, carries 32 PCIe lanes. And as you can see, there's actually power for graphics cards right there. But it's a super slim, small connector. I just realized we don't have TPM 2.0, unless it is somewhere else. I don't see it. I might have to fix that down the line, but I'm not really too worried. I never really use TPM. We also have this 1X connector, which will show off what it's for in a second. But for now, we have this dual 16X PCIe riser. Each card faces a different way. That's why they're at different heights. And in that, we're going to install the same exact configuration we installed in the other server. So we have some more of these Intel X520 low profile 10 gig NICs. We're going to be putting 2 of those in, one for direct pass-through for the router and one just as a spare / optional upgrade. Like if we need to upgrade from 10 gig to 20 gig internet at any point due to, customers or whatever, it'll be best to just have a second NIC rather than having to do some kind of upgrade or some kind of software-based routing that I just don't think is necessary when we could just pass through a hardware NIC straight to the virtual machine. What we're also going to put in this riser, so we're going to put one of those in. We're also going to put another one of these NVIDIA A2s. Now what these are for is there's going to be a VM on each of these servers. There's actually three. Two of these in an ASRock server that each have an NVIDIA A2. So there's going to be 3 A2s available in our data center stack. And these are going to be running basically in code. They don't have AV1. They're only NVIDIA A2s, but they have AV1 decode, no encode. But they can do H.264, H.265, and all that. So they'll be encoding some of the Twitch streams that we run.
Haha, just kidding. Never mind. Because we got banned from Twitch.
These are going to be doing encode, and it's going to be 1 VM per server, so we'll have 3 encode VMs, and something just fell. Probably something expensive. Anyways, having one of these per server means that if we lose a server or something like that, we can just quickly recover our virtual machine and spin it up where another A2 is, because we have 2 streams right now that need the encode, which means we can either add more streams, or can use one as a cold spare. So anyways, or actually be a hot spare. So let's see, putting this in one-handed is basically impossible, so one sec. So we've got our A2 in, and now we're going to throw in our NIC. Well, the server. Well, this server is designed for virtualization stuff, so it is designed for these low-profile virtualization cards. They just don't really fit so well. Hold on. So we're going to pop out this, like, blue thing, because it's a retention bracket for our next NIC, which is right here, and I put these on backwards. The NIC was supposed to go here, and this was supposed to go there. Well, one sec. And there we go, we have our little brick of power. So we've got a 10 gig NIC and our NVIDIA A2. So we're going to try to pop that in one-handed into these very delicate connectors that will basically brick this server if they break. So let's see if we can pop that in here. Actually, the first thing we want to do is, because it has to go there, is you want to fill out this other, oh god, hold on, let me pop that down. I want to fill out this other port right here, which we're naturally just going to throw another one of those NICs into, so one second. I forgot, it's just sitting right here. This appears to be our last one with these low profile brackets, so we got to make it count, and we can just shove that in there. We can just shove that. Okay, this needs to come off. Can just shove that in there very brutally, and that's in. Then we can pop in our secondary riser. Ooh. Crunchy. There we go. And now our server is configured similar to the other one, but we have one more little thing to add in, and then some drives. I dropped a micro SD card in there. You can kind of see it down there. Dang it. Well, this was an inconvenient time to get rid of all my pliers, but I was able to get it out, and hopefully without damaging our cables too much. So, we've got these dual SanDisk high-endurance SD cards, 32 gigs for booting our drives, but you'll notice we don't have that same riser that's a RAID card for microSDs. Thankfully, you can just buy that on eBay. So it's PCIe 1X, it goes to 2 SD card slots. You just pop that in like so, and then we just pop our dual SanDisk microSD cards in there. And then now, like I said, the RAM's a bit slower and we don't have any blanks, but our system is now configured almost identically, at least in terms of RAM capacity, PCI Express cards, and like I said, around a similar number of CPU cores, similar performance. I don't remember how this went in. Like that, apparently. And now we've got a fully configured server. So, this thing has its boot drives. 2 of the bays in the front will be for boot, and we're actually going to throw some of these Kingston drives in over here. Guess we'll show off the front bays now. Like I said, I don't know how I have... Are all these Kingstons? Yeah, they are. These knockoff drive bays, drive sleds that I bought don't work so well. But, yeah, no, these are all Kingston drives. Did I accidentally use a 2 terabyte here at some point? 2 terabyte, there we go. We found the imposter. So now we throw in one of our 1 terabytes here. See, the latch there doesn't properly open far enough for it to shove in. But in order to open it, you kind of have to break it a little bit and then shove it in and lock it, which is super annoying. How hard is it to make a good knockoff? Okay, so we'll put our 1 terabytes in here where they fit, because this side doesn't have... So I lost it. I had a 2 terabyte and I just straight up misplaced it, like right in front of you. Now I know these say 3.84 terabyte. It's just because those are the genuine ones I had that were labeled that. Oh, this server is going to be all genuine ones. Hell yeah. And we have 2 genuine NVMe ones as well. We'll use for NVMe drives. And now that gives us 6 1 terabytes, so 6 terabytes of SATA here, 4 terabytes of SATA here. This top one will have 6 terabytes of NVMe, and this bottom one will have 4 terabytes of NVMe. So we'll have 4 and 4 boot and 4 and 4 boot. This one will boot off NVMe's. This one will boot off of SATAs because, like I said, that's how the drive bays are configured. Although it'll boot off of these SATAs, not these over here. These are NVMe's. Anyways, that's how it's configured. So basically, we've got our servers all up and ready to go. We'll be remote managing them over iDRAC, which I'll show off a lot more later once we have everything remote. And iDRAC is super cool. It's their remote management IPMI stuff. It's super awesome. You can set up accounts and everything. So that's how we'll be doing our bare metal hosting, by just giving someone an account. Then you can flash an OS and everything remotely. So anyways, these are our 2 servers. Hope you guys kind of enjoyed another one of these videos. Last thing I want to point out, this E560F, not E560F, sorry. This R640 has 750 watt, 80 plus platinum power supplies. And the E560F, which is the VX rail system, actually has dual 1100 watt, 80 plus platinum power supplies. They are redundant, and they work better at 208 volt like everything does, so they'll be at 208 in the data center. But that was really interesting that this server is clearly designed for more like CPU, RAM intensive tasks, because it's got, it's only got, it has all the NVMe's and maybe storage accelerated, while the bottom one is clearly intended for graphics cards like this. But we only have one in there, a 75 watt card. So anyways, yeah, we've got 2 seemingly identical systems back here, ready for all of our fiber optics and stuff like that. And they'll go into our 48 port fiber switch. So hope you guys kind of enjoyed. If you guys want to see anything else or stuff like this, just leave a comment, maybe leave a like, so I know that everyone is continuing to like these videos, which, like I said, we're getting a ton of support on them, which is like super awesome for a small channel. So thanks guys, appreciate it. Anyways, I'll see you guys in the next one. Peace.